from this point forward. So we might make a start because I'm super conscious that everyone has rushed to get here, and we are aiming for a 5 o'clock finish. So my name is Clinton Milroy, and I look after all the marketing and events and activities here at Edrolo. I'll be handing over to our presenters shortly, but I'd like to begin just by acknowledging the country that we're all on across Victoria, noting, as I said before, that we've got people dialing in from all across the state. But for us here at Edrolo HQ, just near the Melbourne Museum, overlooking the beautiful exhibition gardens, we are on Bunurong and Woiwurrung Wurundjeri country, and I pay respects to elders past, present and future, as well as to any Aboriginal or Torres Strait Islander people that may be joining us today, including on the country that you might be dialing in from. Just quickly before we get started, I think on the next screen I have got all of our contact details in terms of following us on social media. So if you're not already, please jump on over to whichever social channels you're on to follow us. It's where we'll be sharing events, activities. We've got some giveaways coming up, news, all the latest information from Edrolo across those social channels, so that they are there if you're not already following them. And I also just wanted to quickly mention as well, in case you're not aware, given that you're all in the science faculties, that we have just launched our new Year 7 resources this year. So we now have Year 7 maths and science, curriculum aligned, print and digital resources, the same incredible quality that you'd be used to from Edrolo that you're already using with your senior classes, now available for Year 7. If you are interested in learning more about that, we'll have contact details up at the end, but please share with any of your middle years or Year 7 science or maths colleagues that might be keen to check it out. They can trial it and see for themselves with their students. So great. Well, without further ado, as I said, we're aiming for about a 5 o'clock finish. But thank you all for jumping on this afternoon. I am going to hand over to Patrick, who is going to get us started. So over to you, Patrick.
Awesome. Thanks very much, Clinton. Can everyone see, hear me, and see what's on the slides? Cool.
Nice. And so hopefully
awesome.
everyone.
Thank you. Hi, everyone. My name's Patrick, and I work here at Edrolo as well in our content team across a few different things. I'm also going to be one of the presenters for our online videos that you should all be familiar with. And I'm going to talk to you about the study design changes that have come through with the new study design. And we have a little icebreaker here, but just given the webinar format's a bit hard to share it, but feel free to post it in the chat. Which cat kind of describes how you feel about the study design? I'm sure everyone has different kind of feelings about it. Could be good, positive, somewhere in between. Personally, where I sit, I'm probably about a 6. I think I like the changes personally, and we'll be talking about some of them tonight. So overall, just to give you a bit of an overarching view of some of the changes, overall there's less content. So there is less new content being added, and most of the existing content, well, not most of the existing content, but there's content that's just been stripped out or rearranged from other parts of the study design, even from parts of the Year 12 part of the study design, which is overall good news in terms of your own preparation for the study design change. Just means there's not a whole lot for you to have to completely redo, which is awesome. There's been a renewed focus on the physics of contemporary applications, as well as some of the more traditional topics that we've seen in the study design over the past few iterations. Structurally, there's not much that has changed in terms of the arrangement of area of studies. So the main one, for example, is Unit 1, Area of Study 2, which is electricity. It's now been swapped to Area of Study 3, for example. And then in terms of Unit 2, Area Study 2, there are many more options that have been added. So I'm going to jump straight, and what we're just going to do is summarize some of the main changes that have occurred across the 2 units and the 2 area of studies within those units. So looking at Unit 1, the name of this unit has been changed. It's now How Energy is Useful to Society. So broadly, whereas before there was mostly a focus on thermodynamics and thermal energy, and then a little bit about light and electromagnetic radiation, all that to kind of evaluate the science and physics around climate change and the effects of energy in and around the Earth. That's been changed a bit in terms of emphasis. So we don't have any more any dot points about thermodynamics. So all of that has been stripped out, as well as internal energy. And any explicit references to the Stefan-Boltzmann law, greenhouse gases, and human activity on the greenhouse effect, as well as energy transfer on the Earth. All those explicit references have been taken out. And instead, we now have 3 main areas. So we have electromagnetic radiation. So light has been taken out and put as a big focus of this area of study, and is the first section. And it's not a lot of new stuff, as I explained before. It's actually just taken a lot of content from around the other parts of the study design. So the 3 main sections would be describing and what the properties are of waves, then looking at electromagnetic spectrum, which was kind of part of this area of study in the previous one or the current one. And then it looks at optics, which was something that was seen in the Unit 4 area of study 1, so for Year 12. That's now kind of been pulled into Year 11, talking about this big unit just on light. So looking at prisms and, so refraction, internal reflection, prisms, and optical phenomenon and optical fibers. The second section is then on thermal energy, and this has stayed the same, but just with the thermodynamics aspects stripped out. So still looking at specific heat capacity and all that. And then the third section is combining those 2 elements together to look at climate change and global warming. So there's this new dot point at the end, which is apply concepts to climate change and global warming. And that kind of broadly encompasses a lot of those more explicit references that have been removed. So how energy is transferred around the Earth, greenhouse effect and all that. So a lot of that is now implied in that one statement, and there's perhaps a bit of flexibility about how you would approach this. And we can talk more about how we would be approaching this later on. So then area of study 2 is how is energy from the nucleus utilized? So not a whole lot has changed in terms of new content. There's very little new content, in fact, but a lot has been removed. So anything to do with the standard model, things like quarks and leptons and all that are gone. I will say though, and this applies to the climate change stuff that was taken out before, they've actually been put in as options for Unit 2 area study 2. So whilst they're gone from the core study design, they're actually available as options. Also taking out quantitative energy calculations and synchrotron radiation. And now this is just specific focus on nuclear energy and the applications of radiation. So looking at nuclear stability and the fundamental forces, radioactive decay, types of radiation, and then the applications of radiation in medicine. And this is a new part of the study design, but it has actually been taken from one of the area study 2 options. And then the last bit is nuclear energy. So again, not much has changed here, but ultimately this part is about looking at the viability of nuclear energy, which is the new dot point. And that again goes back to the broad changes that they've made to focus on contemporary issues and ideas through physics.
Patrick, I see that Candace has a question in there about the asterisks. I think it was on the previous slide, but I see there's one there next to viability of nuclear energy. What's the asterisk for?
So yeah, my apologies. So the asterisk just means a new dot point. So something that hasn't been seen before in any study design. So So here, with the prisms and optical phenomena, that's new. Optical fibers, I believe, has actually been in the study design before, so ignore that. But then there's also applied concepts to climate change and global warming. Yep. And then for this one here, the viability of nuclear energy, that's a new dot point.
Yeah,
Thanks.
great. And I'll just encourage people, if they do have questions, they can put them in the chat, but the Q&A down the bottom of the screen is also great because they don't get lost then if people answer or ask multiple questions, and they can also get voted up. So I just encourage people to pop questions in the Q&A, and we make sure we have time either halfway or at the end to answer them all.
Cool. Awesome. So that's Unit 1, Area Study 2. And then after this, very little has actually been changed from the study design. So it's really those first two area of studies. So electricity, so now Area of Study 3, not Area of Study 2, nothing has been removed. It is practically the same with just a couple of changes. So one is now looking at a qualitative analysis of voltage dividers instead of a quantitative analysis. So no need to do voltage divider calculations, although it's something you may want to do with your students anyway. And then there was this one dot point which was asking about energy transformations within a list of transducers, and they never specified exactly what transducers that included. Now they have, so it includes diodes, thermistors, light-dependent resistors, and all that. So very much not a lot has been changed for this area of study. And now moving into Unit 2, Area of Study 1, very similarly, nothing has been removed. This very much looks the same as it has previously, except for torque and equilibrium used to be part of the forces and motion section, but now they've been pulled out as their own section, but largely the content is the same. And they've just made some minor changes to equations, which don't materially make much of a difference. So for example, in the previous study design, the impulse equation was I equals delta P, and now it's just been made M delta B equals F delta T, and that's pretty much it. But then they have this new section called Application of Motion, which is a case study to investigate using motion concepts. So tying a lot of different ideas together to investigate something like safety in car crashes. So you could look at airbags, crumple zones, and things like that, and combining lots of different elements of motion that we know do work well together when presented for a case study. So that's a brand new section. And then finally for Area of Study 2, the options. So no options have been removed, but a lot of the dot points have been stripped back. And a lot of that stuff has actually been made into explorable contexts. So if you had a look at the study design in the little preamble for each of the options, what you'll notice is a lot of things that were in the previous study design have been put into this preamble as explorable contexts. So not necessarily outcomes you need to assess, but different avenues that you can explore the ideas that are there. Some new options have been added. So photography, structures, and material to just really broaden out the different areas of physics that could be explored by you and your class. And as I said before, a lot of the removed content from the other areas of studies have been added as options. So origins of matter and physics of climate change. So if you find yourself, instead of going to choose a brand new option, you could just use the material you already have for those topics and explore that further if that suits you and your students. So a lot of the points have been stripped back, but they all include this new component called communicating physics. And this is about having students evaluate sources, looking at different representations and theories. They've also looked at asking to look at social, cultural, economic, and legal influences and applications of physics to opinions on issues. So this is starting to look at science as a human endeavor, if you're familiar with that term from Victorian curriculum. So looking just beyond the nitty-gritty physics, but also the impact of physics in broader society. And I believe that is me for study design changes, but before we move on, if there's any questions that anyone has, feel free to chat them through now. So yeah, I suppose it has ended perhaps with a little bit of just some more in-depth worth. I'd probably say so. That is probably the thing that's most significantly different about the options, if that's what you mean. That's probably a lot of extra new stuff that needs to be incorporated in some way. So yeah, you're probably right there.
Right then. I'll take over if that's okay.
Go for it.
Right, so my name is Jason Wallace, and I am privileged to be in charge of the physics build here at Edrolo. I only just left teaching after 26 years, of which 15 years of it was doing physics, mainly A-level and also some VCE. So what I will do is to give you a flavour of what we've actually done to the textbook, and I can see a few names on the list of people who have actually given us feedback. So what we tried to do was, or what we succeeded in doing, was getting a lot of feedback from teachers, from physics teachers, as well as sort of junior science teachers, as to what actually they really wanted to be enhanced in the book. So one of the main things that I think is really important is the task styles. So we have 44 lessons in the textbook, and what you'll notice is that the number of task styles in all of the sciences has increased by a huge amount. So what we'll be doing with those task styles is making them really, really visible by putting them in 1 to 2 activities in every single lesson. So as it stands, there's only 7 or 8 practicals, which are PDFs online. That will obviously change significantly. So every single lesson will have at least 1 activity, and it will be a specific task type that addresses specific key science skills, and all the task types will be covered. So basically what we're doing is making the task types and the key science skills very, very visible. The other best thing, obviously, is they're going to be Word documents. They're going to be editable, downloadable, fantastic for logbooks, great for lab techs, because there'll be notes and risk assessments, and that will all be done using Risk Assess as well. So that will be probably 60 to 80 activities. Again, we call them activities because they're not always going to be practicals. As you see, when we come to the task styles, there's a lot of different types. So other thing, obviously, is just making these science skills visible. We already have questions on science skills. Those questions will obviously be still there. And what it will do is, with activities which have very simple scaffolded key science skills really visible, and these questions, instead of leaving the current chapter 1 as it is now, it's going to become chapter 11. It will become something that's embedded in nearly every single lesson. So rather than trying to teach science, they'll actually be doing it in really small bite-sized chunks throughout every single lesson, using activities which are obviously really, really engaging. So here's an example of what one would look like. So specific heat, it give you the task type, and again, these will all come from the study design, and then the key science skills, and the key science skills that we're addressing in those activities, you will be able to find the information. So that chapter 11, which is a current chapter 1, will become almost a reference, which is, I think, what it's really good for. It's not the greatest chapter just to read through and try and teach. It's about dipping in and out and doing it meaningfully with regard to engagement and activities. So having been involved in VCAR for the last 10 years, what's really important this time around with the study design is they are explicit. So what you've got to be careful is not to try and do something that you've done before just because you think. If it's not actually in the study design, it's not in there anymore. So what we've done to aid this is to make all our lessons now have a guiding question. So therefore, it takes the information from the study design dot points and puts it into a really bite-sized, palatable question that obviously as a teacher, a learner, and as a pupil, it really, really makes it simple and obvious exactly what the learning outcome is going to be. So that really helps with explicit nature, because we're not interpreting the study design dot point, we are just putting it in much simpler terms. So applications. So we have gone application crazy because that ultimately is the big change in the study design. It's not about physics, it's about an application with a physics and then some numbers and then some units. So we're really, really, really pushing the application, which is why we've changed the heading to theory and applications. So all of our writers, all of them have to have an application in there. It's not just physics for physics' sake. It's about the physics around us and real life applications. So that engagement and those contexts are much more relevant to our learners. So as you can see here, Snell's law straight into lenses. So much, much, much more real life applications, which is fun. Differentiation. So the average physics class is not going to have 80% of kids who are going to get raw 40s. It's going to have a wide range of learners in there. So what we're doing is a huge push on differentiation. So what will happen at the beginning of every lesson, there'll be essential prior knowledge, which students will have some very quick, high success, high value questions to answer, so that can obviously prevent huge barriers to learning, and any misconceptions can be addressed very, very early on in a lesson. So these are examples of the types of question. They'll be at the back of the book. They'll literally take 2 or 3 minutes maximum, but as a teacher and also as a pupil learner, you'll really be able to gauge where issues are, where barriers are, rather than having a kid sit in the whole lesson, never actually realizing it was just something simple. So they will be at the very beginning of the lesson. So misconceptions. Misconceptions are very visible now, and they're very early. They're not hidden in questions. They're ridiculously visible. Heinemann and Jacaranda, I think one of the books has no misconceptions in, and the other one had 2. We literally have at least 1 to 2 every single lesson, because sometimes it's better that you know exactly what not to do rather than what to do. So we've got breakout boxes, which are misconceptions, which are really, really good, again, at preventing those barriers coming up early to learning. Progress questions. So instead of having lots and lots and lots of content and then questions located away from that content, all of the content now will have progress questions straight after. So it means in terms of learning, it's much more bite-sized. Again, it's easier to spot issues. It's not a case of doing lots and lots of content and then doing lots and lots of questions. You do a small amount of content and then you do a small amount of progress questions. All of these progress questions are formative. It's about building an understanding. It's not about actually testing whether you've got it right or wrong. It's actually about doing the question and helping the formation of your knowledge. And again, it's about reducing the content and just making it much more bite-sized and blended with regard to content and formative assessment. So spiciness ratings. So I think it's really important for all learners is that they're visible. All of our questions are scaffolded and they do increase in difficulty, but what we wanted our learners to see is an actual spiciness rating. And what we'll do is have around 40% each of low and medium, and then 20% of the high. And again, this will help pupils in terms of if they're struggling on a question, it's maybe not such a big deal because it's a 3 chili rating. Keen to investigate. So these will be as they were, but what we'll do is we'll link them in the lessons. So where this is relevant, you will see a breakout box of that right next to it. So again, it makes the user experience better because you're not having to wait till the very end. It's actually much more relevant in terms of its location. And obviously these are extension opportunities as well. So this is an example of all the different types of activities that will be available to be downloaded. We will make sure we cover each of them at least once, and then most likely cover the ones that are much more obvious, like say an experiment, more than once. Another thing that's really important is all of these activities, we will be creating them and based on sustainability. So when it comes to, for instance, a practical activity that I've wrote on prisms, it's important that you've got homemade ones as well as ones you can buy. And also in terms of if any particular materials are bought, we will always try and think about which are the most sustainable in terms of they can be reused year in, year out, and they don't create a huge amount of waste. So that's something we're really proud of, and it's obviously going to take us a lot of time, but we've got what it takes and the people to do it at Edrolo. So I'm going to be really proud to actually be part of both physics and chemistry producing as sustainable activities as I possibly can. So obviously these activities also very, very important, very visible key science skills. So visual hook, I think it's really important as a teacher, an ex-teacher, but I still learn a lot, to have a visual hook. So here's an example of the sort of thing that you'll see at the start of our lessons, where it's one of those questions where it's a really, really good question. But ultimately, it's all about the physics, and that's again where the application comes first. The physics around us will come second, and then you've got the numbers and the units. Because I think what's really important in physics is to be able to articulate and understand rather than just do calculations. So the first page, as you see, it's called our landing page, is now almost like a administration hub, because it's always going to have your formulas. It's always going to have your key terms and definitions, your essential prior knowledge, what activities are available for that lesson. It also shows you, so let me move this out of the way, it shows you the study design dot point, but where you've been, excuse me, where you are and where you're going. And then that's a landing page. So instead of having to go to a glossary or to a formula sheet, again, the user experience is improved because it's always going to be in the right location. And what if you noticed here, we've really improved the literacy of the formulas. It's not, to me, just about the formula. It's about what the formula represents and what it means. So as you can see now, the literacy is first and foremost, followed then by the formula. Right. So questions. I will just stop sharing and then look at chat or questions.
There are also a couple, while you're doing that, Jason, in the Q&A. So Candace has asked, do you have any plans to support the assessment variations with Edrolo, i.e. Jacaranda provide example SACs for students and a quarantined SAC for teachers to alter? So we have our, obviously, end of chapter reviews. What we're trying to do is, rather than produce one SAC, one example, every single activity that we do will be linked to a particular task type, which is also obviously a type of SAC, as well as particular key skills. And then there will be questions with every single activity. So rather than just providing one and saying, here's one example, we will be giving the learners possibly 50 or 60 opportunities to really understand key science skills, what SACs can be about, and actually just thinking for themselves. And the next question from Steve about CSV exports, we might come back to, because it might be more one for Dion when he talks through
sounds like
in a moment. But I see David has a question about, is there going to be a separate lab manual for activities?
No, so the activities will be online as they are now, but they will be Word documents and downloadable. So in terms of making a logbook for students, you can choose whichever ones you want and simply put it together as a digital logbook. So they'll be downloadable Word with risk assessments, lab tech notes.
Great. And David has a question, I think, from earlier, just going back through the chat as well. Can you teach, I don't know if it's for you or Patrick, can you teach one section of Unit 1 with another section of Unit 2 to align it with a combined Year 11, 12 class?
Yeah, you can actually teach it in any order you like. There is no rule in VCAR whatsoever. You can do Unit 2 first, Unit 1. There is no order stipulated at all.
Great. Chris has asked, will there be new presenters? I think the answer is yes, because I think Patrick's one of them. But
Patrick Robertson and Nick Howes is doing them again. And Nick was heavily involved in the writing of the new physics study design.
And Steve has asked if you're from Oldham.
Close, Huddersfield.
There you go. You must know the area. Wow.
I've
So
got
was that a yes?
Football team.
Was that a yes to new presenters?
So Patrick Robertson is definitely new, yes.
Yes, yeah.
So we've got the old and wise with the young and dynamic.
Great. Perfect combo. Any other questions from what either Patrick or Jason have covered? And I'll give people a minute or so. You can either put it in the Q&A, and as I said, we'll come back to your question, Steve, about CSV exports in a second, but I'll just give people a moment to put anything else in the chat, any other questions I want to ask, and then Dion is going to give us a quick run through of the platform that people will be familiar with, but some of the changes coming there that will support what is happening in terms of the study design and teaching and learning. So David has asked about a sample of what to expect to trial, which might be a question for Dion as well.
Yeah, that's perfect. I'll be explaining that in a minute. Am I good to sort of go into it, Clinton, and then any?
I reckon make a start, and we can, if people have got questions, they can still post them in. Jason and Patrick obviously sticking around, and we'll get started with your bit and come back to any questions that come in.
Lovely. All right. Thank you for that. So yeah, my name is Dion. I'm just here to take you through what this resource actually looks like. So many of you might use our resources, whether you use the standard resource or maybe a textbook in another subject, or maybe even the physics textbook currently. But I'm just going to run you through for 5 minutes, last 5 minutes of this presentation, how you actually use this. So we have VCE textbook resources for the following subjects that you can see on the screen. There's about 14, I believe, that we've got across the board for VCE textbooks. And then we actually have a new Year 7 resource for science and for maths. So if you are interested in a Year 7 resource that's an all-in-one resource that we're getting incredibly good feedback on at the moment, you can trial it. And I'll give you details of how to do that in a few minutes. But let me just give you a demo of what physics actually looks like. You've heard about the study design changes. You've heard about how we're incorporating that into the physical book and also the digital sort of version of things. But let me flick over and show you what the experience is like for students and for teachers. So firstly, for students, and yes, some of you will have used Edrolo before, but for students, you have access to videos that are linked to the study designs. There are videos you can see for each topic in physics. Here I'm demoing 3-4 physics for the moment. And then you have questions. So I'm logged in as a student and I can go in and complete any of the questions that are in the physical book or in the PDF. I can complete them online, but I want to show you what that looks like for a student. So for a question like this is a multi-choice question in physics. A student can go in, they can click on their what they think is the answer. They can then click on save and continue. And they have to give an indication of, or they're prompted to give an indication of if they're confident or not in their understanding of the question. So this question here, they got the question wrong, but let's say that they've gone to their book and they've sort of read a little bit, and then they sort of indicate they're confident in their understanding. Most of the questions in physics, probably not the best one to demo, most of the questions in physics have a corresponding video solution, and I'll actually show you what one of them looks like now. So the corresponding video solution is associated mostly with the short answer questions. So if a student enters their answer here, they can get a video solution as follows. And I'll give you a quick look at what this looks like here.
This question is really about how can we reduce power loss? Now, whenever we see power loss, we want to think about the equation, which is power loss equal to...
So if you think about how beneficial this is to your students, you can fire them nearly all questions in the textbook to their email address or the learning management system or however you communicate, and they can get a video solution of a teacher guiding them through the correct answer. But they also get this checklist. And this is something that is really, really popular with our Edrolo textbooks. Not only are these checklists at the back of the book, but they're also interactive. So what that means is that students can actually self-mark their own work. There's the answer that I gave, and there's an exemplar response as well. And you can see even when you mouse over those checklist items, they are highlighted in the exemplar response. And once again, students are asked, are they confident or not in their understanding? So this data that students are sort of self-complete, these answers that students are self-assessing, this is really valuable for them, but it's also really valuable for you as teachers, because for every question, you can see how your students have gone about responding to the answers. So as a teacher, you can look at, right, these are my theory review questions. These are the multi-choice questions, and students are answering these questions pretty well. Looks like they're getting them correct because the little green indicates that they're getting them correct. But there's some red here that suggests that the student needs help with the questions. So if we have a look here, a really good way to look at this data is both horizontally and vertically. So horizontally, you can look at individual student performance, and you can see these ones here are the short answer questions that students have completed. And you can actually click in here and you can go in and see, right, this particular student needs help with this question. And if we scroll up a little bit, in fact, if we go to, I've actually got one preloaded here, which is probably a better example. Sorry, Zoom's getting in the way. So I'm just having to navigate this a little bit. So this question is an example. The students have gone through and completed this checklist, and you can see that there's 9 out of 16 students that have answered the question. 1 out of 9 need help. And what you can do is you can see the representation of the checklist here. So that gives you a good idea, right? 5 students didn't relate this change to the power loss equation. And then you can scroll down and you can actually see the students' answers, and you can see how they've actually self-assessed their own work. The other thing that I'll point out as well is as a teacher in physics, you get a PDF, obviously, of the textbook, but also a printable unit plan. And this is a plan that is a Word document. It allows you to edit it, to incorporate it into your current unit plan. So if you're thinking that you're a teacher that is, there's some trepidation in moving to a new textbook, the printable unit plan is a really great place to start, and teachers that switch to an Edrolo textbook really, really love it. Awesome. So the next thing I wanted to mention was there's actually an opportunity for you to trial the physics textbook of the current study design this year with your students, and you can trial it for free. So I want to tell you how you can do that, and I'd love to get you to leave your contact details. We're not going to badger you. We're just going to have a quick meeting with you, and essentially you can, what we'd love you to do is set aside your existing textbook. Let's say for a topic, there's an upcoming topic that you've got, and then for basically just set some work for your students. So send them questions that they can complete. And then if you decide that you actually want to go ahead with the physics textbook next year, we'll actually extend this free access that this is a trial with your class that you'll do with your students, they'll all have access. We'll extend free access for the rest of the year for you and your class. And then if after the trial, if you don't want to continue with the trial, we'll just switch off the digital access, and that's all good. There's sort of no obligation. So what I'll get you all to do, if you're interested in trialing the textbook this year, as I said, it's completely free, is head to this link. Now, I believe Jess has shared this in the chat, edrolo.com.au/physicspl. Just enter your details. It takes about 60 seconds to do. Yeah, you'll be able to trial our textbooks. And this goes both for the Year 7 science textbooks, maths textbooks. I've actually got a Year 7 humanities textbook that you can trial as well. So I'll just check the chat and just make sure. Let's have a look if there are any questions here. This is a question. Okay, I think that got answered. Great. Steve, question regarding the CSV export. So yeah, Steve, that's a really good question. So if let's have a look and I'll show you what it looks like. So at the moment, when you go into a set of questions as a teacher, you can export the CSV. I won't open it now, but Steve, in answer to your question, I believe our team is looking into the sort of usability of that CSV and adjusting it so that it's a bit more usable. So in answer to your question, yes, that's something we're looking into. I should just check with our product team before about that. All right, I'll flick back over here. So we can see that there's already some people that are registering for the trial. Thank you. That's yeah, it's definitely worth your while signing up to a free trial if you anticipate that you might want to use the physics textbook next year. And it's also just giving your students access to a huge bank of really, really high quality questions. And so yeah, it's a really good opportunity to try before you buy. So I'll just give you a few minutes. I can see a few others have signed up to the trial to go to edrolo.com.au/physicspl. Yep. Actually, I should probably mention if you're tempted to trial as well, we actually send you a physical book yourselves. So we'll send you a physical book, give you and your students digital access, and it is free. And yeah, typically we do an 8-week trial, but we'll chat about it with you about what you want to do and when you want to start it, and we're very flexible with that.
Thank you, Dion. Any questions for Dion? Any questions for Patrick? Any questions for Jason? We have run slightly ahead of schedule, but I'm sure no one's going to complain about getting 18 or 19 minutes back into their probably packed, busy evening. Just going to recheck the Q&A, make sure we're not missing anything. When will the new Unit 1-2 course be live for enrolments?
It's an excellent question. So we typically have the textbook ready for early commencement or Head Start period. So it's typically in October, November, and then the books are printed in January. But we've been pretty good with getting that all out in time. And yeah, I believe that's the time frame.
Great. And David has just asked if we're already using the textbook, will the new one need to be trial?
No, look, if you're using the textbook and you like the textbook, you're going to like the textbook more next year because there's been a lot more work put into it, as you've heard today. So there'll be no need for you to trial it. I'd recommend just signing up, and you and your class will already have access to the textbook this year. So yeah. In terms of getting a copy of the new one, they haven't been printed yet, but what we can do is we can send you a sample of a chapter. David, if you would like to see a sample of the new textbook.
I think Campbell's are.
Yeah, and Campbell as well. Yeah.
So they should be ready sort of mid-July is the date, the latest date.
Wonderful. We can see a few more people have signed up to the trial, which is awesome.
And we are going to do chapter 1 because there's some really good new stuff in there with rainbows. So we're really sort of, I think we're putting forward which was the hardest chapter for us to write, but it's an absolutely fantastic one. Trying to do diagrams of rainbows and double rainbows was very interesting.
What a day to be talking about rainbows. We had one outside the Edrolo office earlier when the rain was passing. I missed getting a photo of it, but
James just asked a question: is there a way to see student progress on questions videos over a certain time interval? If I check on Monday, can I see who's made progress from Wednesday or previous week? That's a really good question, James. I haven't heard that suggestion before. I'm going to copy paste your question, and I'm going to pass that on to our product team. I think being able to filter by time is actually a really good idea. So thanks for the suggestion, Jason. James, I mean. And Jason, if you've suggested it previously.
Any other question? Is there a possibility of getting a student completion view page?
There is actually a student completion view page, and it's something that was introduced, I believe, a couple of months ago. I can quickly show it to you. So if you want to zone in and see how a student has gone in terms of their questions and their videos they've been watched, let me show how you get to it. So essentially, you click on a student's name in any part of the platform, and it allows you to see on an area of study basis, and then drilling down into the lessons, videos that have been completed, if there's any quizzes there, but also textbook questions and self-reflections. And then you can even get more data on that by looking at the individual student responses. And you can even click on them and it zones in right to that particular textbook question response. So that's just clicking on a student's name on the platform.
Great. Anything else? Last call. Any final questions for our panelists this evening? No? Great. Going once, going twice. Done. I think we are done for this evening. So thank you all again for joining us online. We have shared contact details in the slides. you can reach out and ask us anything. We will today, not now, tomorrow or Thursday, we'll be sending out an email with a recording of this webinar. So feel free to share it with your colleagues or anyone who wasn't able to make it. That email will also include the slides from today, as well as your certificate of participation. So that will all come through via email. So watch out for that. So hope you all have a lovely evening. Stay safe, stay warm, stay dry, and we'll hopefully see you all again soon. See ya.